This series of lectures will be about the vascular system. Unlike in anatomy where we trace the drop of blood, now we're going to look at how we regulate the vascular system. And I drew this out just so that we have a basic idea of the blood flow pathway. We start at the heart in a ventricle, and then we go to the elastic arteries like the aorta and the pulmonary trunk. We then spread out to the muscular arteries, go down to the arterioles, go to the capillaries, which is where all the work takes place, all the gas diffusion, nutrient diffusion. Then we collect back into venules, small veins, large veins, and back to the atria of a heart to go back into a ventricle to make the rest of the pathway. But this is just to give you an idea of where we are going. So the key with blood flow is that much like ions move down a concentration gradient, blood flows down a pressure gradient. When we think about it, we're looking at how the pressure falls. So the arteries, we have very low pressure fall. Across the arterioles, we have a large pressure change, and then the capillaries and the veins. And so one of the reasons why I presented in lab was that the ventricle, in diastole goes to 0 is because these veins here are almost at 0. And so we have a very low difference in pressure. So we have to make sure that it's as good as it can be, versus the ventricle during systole creates the pressure to push the blood into the arteries. And this graph also shows that the pulmonary is much lower pressure than the systemic, because that is how we're going to deal with the length difference. So, and we already have seen that the right ventricle has a thinner wall than the left ventricle. So down our pressure gradient we go. So this is just kind of a look at the vascular system itself. Blood flows through the arteries. And we have oxygenated blood from the heart here at the top. Oops, why did that not go? Here at the heart. Starting here, goes down the arteries. You notice that all blood vessels have endothelium. And then we have a layer of smooth muscle and a layer of connective tissue. We branch off from the artery to go to the arterioles, that then is going to go to the network of capillaries. The key thing with a capillary is that all we basically have is the endothelium and the basement membrane connective tissue. There's very little connective tissue here. The basement membrane of the endothelium itself is all that basically holds these together. And then we're going to reconnect through the venules and go into the veins. Now, the veins, this is systemic because oxygenated versus deoxygenated, but have much less smooth muscle. Everybody has endothelium, and you can see how they have artistically included the valves that are in the veins. We'll talk about those. So all the nutrient exchange, all the gas exchange, everything happens here in the capillary. The job of the arteries is to send the blood out. The job of the veins is to bring the blood back, and it needs to do so as quickly as possible. Capillaries is where we slow things down and actually allow that diffusion to take place. So definition time. Compliance. Compliance is defined as the relationship between pressure and volume changes. And we kind of think of this as the ability to stretch. And we'll talk about compliance in the lungs and compliance in the arteries. But the idea is if I add volume, how much is that vascular system able to stretch in response to that increase in volume? And the lower the pressure it does so at is higher compliance. So veins have a really high compliance. This is why we add fluid to the venous system, like for IVs, is because they can stretch, they don't have a lot of pressure, and they'll move the blood forward. But arteries also need compliance. Now, your textbook says they have very low compliance because every time we add volume, we get an increase in pressure. But I want you to think about the difference between compliant and non-compliant arteries. We talk about people who have hardening of the arteries. We talk about people who have on non-compliant arteries, and they have huge jumps in pressure versus moderate jumps in pressure. And this is where we get, the concept of arterial sclerosis and hypertension is because of these non-compliant arteries. But as we think about how things stretch in response to volume, that is compliance.